I need to put some more back there, don't I? Take that one back there, and I'll get another one up here. All right. Okay. Let's see. Graphing exponentials and logs. All right. So graphs of exponentials. Let's start here. Okay. Now, if I want to make a graph for an equation, all I need to do is plug in numbers, and it gives me the y coordinates that go with those x's. So, like for example, if I want to make a table for y equals 2 to the x power, right? I could just plug in numbers. I've picked a few here. Anybody know how to do 2 to the negative 1 power? Anybody know? It's going to be 0.5. Did you type it in or did you know it? Typing it in is fine if you typed it in. Typed it in. Does anybody know how to do that without typing it in? Do a little bit of negative exponents in Math 1, but I know that's probably a topic that you were like, don't know about. And we can use Desmos on everything, so typing it in is perfectly fine. It's going to give you 0.5. I'm going to hold off on it for a second, just to, it is going to be 0.5, but just to show you, where that comes from, okay? What is 2 to the 0 power?
0.
It's not 0. Type it in.
1.
It is 1. That's weird, too, isn't it?
I forgot that.
It's weird. I'm going to show you why that's the case here in a second. What is 2 to the first power?
2.
It's 2. That goes here. What is 2 to the second power? 4. That goes here. 2 to the third power is 8. That goes here. Okay? Now, let me show you, sort of why something to the 0 power is 1. Let's say that I wanted to start right here, and I wanted to get to this number right here. What could I do to get from 8 down to 4? I want to go from 8 to 4. I could divide by 2. I could also subtract 4, but that pattern wouldn't hold, right? So if I divide by 2 again, 4 divided by 2 would give me 2, right? If I divide by 2 again, then I'll get 1, right? So if I divide by 2 again, what would I get? Not 0.1. 0.5 or 1/2 right there, whichever one you want to see. For negative exponents, what you have to do, if you had me, I told you that negative exponents were like bad children. What do you do to bad children?
You hit 'em.
Nope, don't hit them.
You whip 'em.
Nope, can't whip them.
Hey, Joe.
Anybody from Math 1 remember? You lock them in the basement.
Hey,
That'll
wow,
fix
that
it.
is so much
Every
better.
time.
So
So
much better.
you negative exponents, you got to send them to the other side of the fraction bar, and it fixes their behavior, and now they have a positive exponent instead of a negative exponent. So we got to do a little bit with negative exponents on down the road. So I'll teach you more about child discipline later about that. It works. Now, this does not work if you have a finished basement. If you have a nice basement with couches and TVs and stuff, will not work. But you need a scary basement with a furnace or something. That'll do it every time. No. Obviously, I'm picking.
Did you ever do that to your children? How old are your kids most high?
7 and 13.
One's getting
Yeah. No, I have not locked my children in the basement. In fact, our kids get in trouble for going to the basement a lot of times because we got it's not finished, but we got a workout area, and my 7-year-old just goes down there and drags things out. You go to, the other day I went down there in my exercise bike, all the knobs that you use for adjusting it are laying over in the floor. He just unscrewed them so far that they fell off, and then he couldn't get them to go back on, so he just left them laying there. So they get in trouble for playing in the basement a lot of times.
one of those underground basements where it's not finished, so it's like a dungeon. But my dad used to be down there all the time when he's living upstairs, so it's just concrete and damp and dark.
Yeah.
So gross.
Yeah.
That was just
All right. -1 is 1/2. So this is what it's going to look like. Let's draw this in. Make sure you plot these points and draw these in. Now, an exponential never drops below 0 because negative exponents don't give us negative numbers, right? So whenever I have this, like even if I had 2 to the -10th power, it would be 1 over 2 to the 10th power, and I'm not sure what 2 to the 10th power is, but if you grab your calculator and check there, 2 to the 10th is like 1,024. And so even when you have really like big negative exponents, you don't get a negative number. You get 1 over a really big number. And 1 divided by 1,024, what number is that really close to? What? It's not close to 1,024. 1 divided. So that tells you, the bottom tells you how many pieces. So imagine that we have a pizza. And we're going to split it into 1,024 pieces. So we get out the slicer and we slice it into 1,024 pieces, and I give everybody a piece. How much pizza did I give you?
0.5 of it.
Yeah, essentially nothing, right? Pretty much nothing. So what happens over here? Another way to think about this is, let's say that I'm going to walk halfway to that wall. Okay? So if I'm going to go halfway to the wall, right, from here, I would end up about right here. Something like this, right? Okay? Now if I'm standing here, and I want to walk halfway to the wall, 1, 2, 3, 8 blocks. I need to go over 1, 2, 3, 4 blocks. I walk halfway to the wall. Okay, if I walk halfway to the wall again, I got 4 blocks left, and we'll go over 2 blocks. If I walk halfway to the wall again, 1 block. Okay, if I walk halfway to the wall again, half. Am I ever going to get to the wall?
Probably.
Theoretically, if I'm a point with no width, obviously I have some width, but if I am a point with no width, do I ever make it to the wall? No, I don't. So that's what's happening here on this side of the graph, right? This is getting closer and closer and closer and closer to 0, but it never actually gets there. Okay? Does anybody know what that's called whenever we get closer and closer and closer and closer to a line, but we never actually get there? Starts with an A. A, S, Y. Oh, I think I heard it over here. No, that's not it. You're close, though. Asymptote. Have you ever heard that word before?
No.
Um,
If you use lecture like
Hmm?
use lecture as
A lecture of asymptotes? Not exactly. So let's label that on here. So this line right here, in this case it's the x-axis. I'm going to draw myself a line. This is not part of your graph, but that x-axis is what we call a horizontal asymptote. A-S-Y-M-P-T-O-T-E. Okay, so it is a line where we're getting closer and closer and closer to that line, but we never actually go across that line. So on this side of the graph just gets closer and closer and closer and closer to 0, but never actually gets there. Okay, on the right side of the graph, it's exponential growth. It just gets higher and higher and higher and higher, more and more and more quickly, right? Because you're going from 2, 4, 8, 16, 32. It just keeps doubling over and over and over. which means it's going to be growing really quickly at the end, right? The domain of an exponential, if we have a basic exponential, which is all we'll look at here, if you get something crazy where you're like 2 to the x squared or something crazy might happen. We're basic exponential, so your domain is always all real numbers. Or if you're using interval notation, negative infinity to infinity. Because if you think about what we did for domain, right? Domain, we're thinking of, does it exist out here? Yes, it does, right? Does it exist over here? It does. Even though it doesn't look like it's hitting it, it's going up forever. It's going to eventually touch the graph. So your domain is always all real numbers. The range of an exponential is, I'm going to just say that it is restricted. So it is not going to be negative infinity to infinity. What would the range be for this one? Okay. Remember, for the range, we're thinking, what's the very lowest that you ever go on this graph? It's not going to be infinity. So, it's 0 is your lowest, but you don't actually get there, right? How can we show that when we're writing the range? If I put a parentheses, does that include 0? It does not, right? Remember, bracket includes 0. So we wouldn't want to use a bracket here. We'd use a parentheses up to infinity. Because the lowest you will ever go here is 0, but you won't get there, so you want to use a parentheses. The highest you'll ever go, this just goes up, up, up forever, so it's infinity. Okay? So this is what a graph of an exponential looks like if it has not been transformed any, if it's not been moved up, down, left, right, flipped over. We're going to see some of that tomorrow when we look at transformations. Let's look at I already had horizontal asymptote here. I've forgotten what I put on my own notes. An asymptote is a line or a curve. It can actually be a curve like you won't see that. That would be a much higher level math than here. We're only going to see lines. That a function approaches. All exponential functions that we will look at in this course have horizontal asymptotes. Horizontal lines, which way do they run? Like this, right? What's this called? Vertical. These will be horizontal, right? The equation of a horizontal line is given by, for example, what's the equation of this horizontal line right here? It's going to have something to do with -3. That dotted line right there. So horizontal and vertical lines are either x equals or y equals a number. Okay? Think about the points that are on this line right here. This would be 1, -3. This over here would be the point 6, -3. Over here would be the point -5, -3. What do you notice about all those points? Okay, you all have -3 for what? The y. It's going to be y equals a number. It seems backwards. Like this particular line is y equals -3. It seems backwards because the y-axis, is it horizontal? It is not. Y-axis is vertical. But this is backwards. Y equals a number are your horizontal asymptotes. X equals is going to be vertical. Okay, questions? All right, let's keep going. All right, end behavior. This is talking about what happens at the far ends of the graph, as far as you can go on the left and as far as you can go on the right, okay? So often we want to describe what the graph is doing for very large numbers, either positive or negative. To describe this, we write, as x approaches negative infinity, y, or sometimes f of x, just depending on which one you're using for your equation, approaches blank. And as x approaches positive infinity, y or f of x approaches blank. Okay? So the first one right here, if x is approaching negative infinity, which side of the graph are you looking at? Okay? It's going to be left side. So this is the statement you would use for the left side of the graph. Then, if we got x is approaching positive infinity, which side of the graph is that? That is your right side of the graph. Okay, so let's look here. All right, so they have given us an equation, and they've given us the graph. We are supposed to find each of the following: domain, range, asymptote, end behavior. Okay? All right, now the first one, you need to memorize this and have it seared into your brain. What is the domain of an exponential function? We wrote it down just a second ago. Not for domain. If you go back a couple slides, the domain of an exponential is always, what'd you put in that blank? It's always all real numbers or negative infinity to positive infinity. So domain, you're thinking about, does it exist over here? Yes, it does. Does it exist over here? It does. Sometimes this looks so steep, it looks like it also has a vertical asymptote. It does not. It is always going to be all real numbers for that domain. So if you just memorize that, negative infinity to infinity, you'll get those right every time. So any exponential is going to look like that. But range, Trinity, what do you think about the range for this one? Very good. So -4 to infinity. I know with infinity I've got to use a parentheses. What about that -4? Should I use a bracket or a parentheses? Do I ever get to -4? It looks like I do on this graph, right? Because Desmos, is it going to be able to graph 1 over 1024 or something even smaller? No, it's going to look like it hit the line, all right? But this is one of those things, if we had it on the actual Desmos graph, you can zoom in, you haven't actually hit the line. So that's going to be a parentheses for that. Okay, our asymptote for this graph, we're talking about this horizontal line that we get closer and closer and closer to, but we never actually touch. Okay, what is the equation of that line going to be? What is it going to be? We wrote down y equals what number? -4. Okay? For a horizontal asymptote, it's always y equals whatever the number is. Okay? And then end behaviors, the last thing we got to do for that, as x approaches negative infinity. So negative infinity on the x-axis is over here on this side. That is the left side of this graph. As I go to the left side right here, what's happening to my y values? Are they going up forever, down forever? Are they leveling out at a number? They're leveling out. What number are they leveling out at? -4. -4 is my answer here. This expression here, as x approaches positive infinity. Positive infinity is way over here on the right side of the x-axis, right? As x approaches infinity, so if we're following this graph on the right side, what is happening to my graph? Up forever, down forever, leveling out. Up forever. What are the y values getting closer to? As they go up, 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 up. Infinity. Positive infinity right here. So, if it goes up on that side, it'll be positive infinity. If it goes down on that side, you'll get negative infinity. If it levels out, it's going to be whatever that number is that you're leveling out at. Okay? Questions? All right, let's keep going. We need to look at graphs of logs. Okay, so for this, I've got to do log base 2 of 0, log base 2 of 1, log base 2 of 2, and so on. Okay? In fact, I might need to adjust my table a little bit here. Now, some logs I can figure out without a calculator, but we really did not do that very much, right? So let's just look at Desmos. Over here, and I just want to know like what log base 2 of -1 is. Oh, what's it tell me? Can I graph that? No. Okay. How about log base 2 of 0? Still undefined. This is weird. Okay. Let's see. Let's go 1. Okay, now we're getting an answer. We got 0. So 0.10 is right here. Okay. 2 is 1. So 2, 1 is right here. 3 is 1.584. So 3, 1.584 would be like right here. Now that does not tell me very much. I'm having a hard time seeing what this graph is going to look like just from that. Let's plug in some bigger numbers, like let's plug in 5. If I do 5, I'm getting 2.32. So 5 would be a little above 2 right there. Let's plug in 10. I got 3.32. So that'd be a 10. So 1, 5, 6, 7, 8, 9. 10 is actually like right here. I'd be just a little above 3. So this side of the graph seems to be doing like this, like going up, but going up pretty slowly. When I plugged in 0 and -1, I got undefined. Like, what if I plug in like -5? Still undefined. -10, undefined. Does it look like negative numbers are working? It does not. All the way to 0, I think I've got nothing. What about between 0 and 1? Do you think? Let's give me a number between 0 and 1. 0.5. Okay, now if I plug in 0.5, I'm getting -1. So 0.5, -1 would be right here. Okay. Can you give me something even closer to 0? 0.1. Oh, 0.1 gave me -3.3. That'd be like right here. Can you give me something even closer? 0.01. Oh, that gives me -6.6. Now, 0.01 is going to look like it's practically on 0, right? Anything closer? So another 0 right there. Oh, that's like here, right? What do you think we've got right there? What does it look like is happening? If I get closer and closer and closer to this vertical line, this just keeps going down forever, right? It is the asymptote, but this time it's not horizontal. What is it? Vertical. So what looks like's happening here is I've got a vertical asymptote for this graph. Right? No. And I'll write it on the next slide because I've got the slide on this. I forgot to have one. Last one. All right, so the domain of a logarithmic function is always restricted. Okay? So like for this particular problem, if I think about my domain, what is the furthest to the left that I ever go on this graph? 0. Do I actually get to 0? I do not. What's the furthest to the right I ever go? Infinity. So this would be, my domain here would be 0 to infinity. But I'd have to use a parentheses with that 0 because it's never actually included. Okay? Now, the range of a log function is always negative infinity to positive infinity. Think about this. Logs and exponentials are inverses, right? So what do we do when we find an inverse? We switch our x and y's, right? So would it make sense for logs and exponentials that the domain and range would switch, which is pretty much what's happened here? For a log, your domain is always restricted. Your range is always negative infinity to infinity. For exponential, it's the opposite way around. Domain is always negative infinity to infinity. Your range is restricted. So that should kind of make sense why that happens. All right, so let's look at vertical asymptotes. Vertical asymptotes operate just like a horizontal asymptote. It's just the values that you're looking at are opposite because this is going to be vertical. So all logarithmic equations that we will look at in this course have vertical asymptotes. And the equation for a vertical line, like if I look at this graph right here, if I pick points on my dotted line, this would be the point 2, 7. This down here would be the point 2, negative 3. Right here is 2, 0. What do you notice about those coordinates? What is always 2? The x is always 2. So it's x equals a number. And so like for this one, your vertical asymptote would be at x equals 2. You guys have a big advantage because you can use Desmos on your whole entire test. And so if you're not sure if you got the asymptote right, you can just type in x equals 2. And if you were expecting a horizontal line and it graphs a vertical line, you'll know you've got the wrong letter. It needs to be y for that. Okay. Next problem here. Okay, we've got the graph of y equals natural log of x minus 1 plus 3 is shown to the right. Find each of the following: domain, range, asymptote, and behavior. Now, you will notice one different thing on our end behavior here that's going to show up. We'll look at it when we get there. All right, domain for this particular problem. What is the furthest to the left that we ever go? 1. Should I use a bracket or should I use a parentheses there? Parentheses, because I don't actually ever touch 1, right? It gets closer and closer and closer. What about furthest to the left? Furthest to the right that we go? Infinity. It keeps on going forever. So 1 to infinity for our domain. We just wrote this down. What's the range always for a log? Negative infinity to positive infinity. A lot of times if you actually graph these over here in Desmos, like if I type this over here, y equals natural log of x minus 1 plus 3. A lot of times if you zoom out a lot, it's going to like look like you might have a horizontal asymptote there. You don't. It's going to keep climbing. Like for here, maybe it looks like my horizontal asymptote is at y equals 10. Like that looks like a horizontal asymptote. But if I zoom out far enough and go over here, I might have picked something too big. If you go out far enough, they are going to cross. I promise. It's not very convincing. Oh, I see it right there. Right there. They do cross, right? They do eventually cross for that. So for range, it's always negative infinity to infinity. What is my asymptote for this one? Okay, what equals 1? Okay, x equals 1. And that's, one of the beautiful things about being able to use Desmos. I can go over here, I type in x equals 1. Oh, look, it looks like my vertical asymptote, right? If I type y equals 1, I'll be like, oh, no, that's horizontal line. That's not what I wanted, right? So I'll get rid of that. There. Right, it's going to be where that line sort of stops right there. You can find that for sure. Right, very good. Okay, all right, so end behavior. Now, notice I did not put as x approaches negative infinity here, like I did for the other problem. I did not do that because does x ever approach negative infinity over here? Our graph does not exist way over here at negative infinity. What's the furthest to the left we ever go? 1. So on the left side of our graph here, for a log, on that left side, x is not going to approach negative infinity. It's approaching 1. It's getting closer and closer and closer to 1. What you'll see is whatever is your left side of your domain, that's the number that goes here whenever we're talking about logs. What is happening is I go to the left. What are my y values doing? They're going down. So what should I put for y approaches? Negative infinity. All right, what about as x approaches positive infinity? On this side, what's happening to my y values? They're going up. And even though they're not going up very fast, because they're not, they will continue to go up forever. They'll go up to infinity. Okay? Hold on. Okay, let's just talk real quick about exponential growth and exponential decay. Okay, so we did this in Math 1 long ago, very, very long ago. The standard form of an exponential function is y equals a times b to the x. A is going to be your initial value. It's whatever your, like, f of 0 is. B is your growth or decay factor. And x is always some sort of time. In this case, it could be minutes, hours, days, months. Sometimes it's not really like a time frame, but it could be like the number of rounds in a tournament. Like you have exponential decay in the NCAA tournament, right? You start off with 64 teams, then after the first round, half of them are gone. And then after the next round, half of them are gone, right? So that would be an example. Like it's not necessarily an amount of time, but it does represent time passing there for that. So when you see exponential growth, it's going to look something like this. Exponential decay looks something like this. Both things happen a lot in the real world. Exponential growth, you can think about like population, bacteria growth, compound interest for a bank account. That looks like this. Exponential decay also happens a lot in the real world. This would be like half-life for radioactive substances. It would be the depreciation of your car. So when you buy a car for $40,000, it doesn't take too long for it to only be worth half of that, right? Half-life for medicines are really important. So, like, whenever you take a medicine, you got 400 milligrams of ibuprofen in your system. Your body's processing it as your, like, liver and kidneys or whichever one it affects the most there is filtering that out, right? So that decreases, and eventually you'll have just little tiny trace amounts, and then theoretically never zero, but essentially pretty much zero for that. This is why if you were to go this weekend and ingest illegal substances, and then they, a few weeks later, called you up there for drug testing, I'm not looking at anybody because y'all are angels and would never do something like that. But if you did go ingest illegal substances and then they call you up for drug testing, even though it's been a couple weeks since you did it, when you go pee in the cup, they can still tell you're not currently high, right? But they can still tell because your body is still processing. Those are like teeny tiny trace amounts that are there. It's not affecting you at the moment, but little bits are still there. That's exponential decay that's happening right there. Now, eventually, it's going to get below traceable levels. So if it's been 3 months, then you might be okay if you get called for drug testing. But I think they usually say, like, within a month, they can still find it, I think. So it's good to know how things like that work. But you guys are not going to have to worry about that because you would not do those things. I know. There. When you're looking at these equations, this B value, that number that's being raised to the power, is what you're going to look at. If B is greater than 0, greater than 1 right here, you are going to have exponential growth. If the B value is between 0 and 1, so you have a decimal or a fraction there that's between 0 and 1, you're going to see exponential decay for that. So, let's just look at this. Without graphing, determine whether the example is exponential growth or decay. All right. So if we want to know if this is exponential growth or exponential decay, right here, which number do we need to look at? Number inside the parentheses, the one being raised to the power. If I've got 0.0 or 0.12, is that growth or decay? That is decay because it is less than 1, right? For B, the number inside of the parentheses is 5. Growth or decay? Growth. Pretty rapid growth here. Multiplying by 5 each time. Okay? What about C? Decay. For that. Okay, I think we got one more. We're not going to have time to do all this, but let's do one of them. Which one do you guys want to do? 3, 4, 5, or 6?
5.
I heard 5 twice. Let's go with it. 5. All right. We're going to use, actually, first of all, well, let's use Desmos. Y equals 2 to the x plus 3. All right. So, what is my domain for that? Oh, yeah. That makes a big difference. Thank you. That needs to be in the parentheses. Up there in the, okay, that looks better. All right, what is my domain for that? Does it exist way over here? Yes. What about way over here? Yes. That's negative infinity to positive infinity. That one is a exponential. Your answer should always be negative infinity to positive infinity for your domain. In fact, number 6, what's the domain on number 6? Negative infinity to positive infinity. I know this even without graphing because it's an exponential, right? What's the range of number 4? Negative infinity to positive infinity. I know it even without graphing it because logs always have a range of negative infinity to infinity. What's the range of number 3? negative infinity to positive infinity. So with logs, your range is going to be all real numbers. With exponentials, your domain is all real numbers. Let's go back to this one. What's my range? What's the lowest y value I ever go to? 0. What do I go up to? What's the highest? Infinity. Parentheses with both of those. X-intercept, where do I cross the x-axis? It does not. There's none. Because that is a that is a horizontal asymptote. I never actually get there, right? Y-intercept, I'm just going to point to the point. I get 0, 8. What's my horizontal asymptote here? It's 0. What letter equals 0? X or Y? Let's see if I type it in. X equals 0. Oh, no, that's vertical. That's not what we want. We want Y equals 0. Is my asymptote. And for my end behavior, as, I'm going to write it really short, X approaches negative infinity. That's the left side. What does Y do? Y approaches on the left side. What's happening to our Y values? Are they going up forever, down forever, leveling out at a number? On the left side? Levels out at what number? At 0. Okay? As X approaches positive infinity. What happens on the right side? What happens to our Y values as we go to the right? Up, 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 which is going to be positive infinity. Okay? We will